Let's continue. Okay, there we go. Recording started, everything's working. All right, I can start sharing my screen here as well. And let me put this up in the corner. That's interesting for some reason. Huh, that's interesting. Just give me a second to figure out Zoom. It's so weird. What if I do this? You guys can't see it though, huh? I'm assuming this is just black for everybody?
Yeah.
Huh. Interesting. How did I do this last time? Hold on. Oh, it went over there for some reason. Okay. Okay, there we go. All right, is everybody able to see the video on the screen at the same time?
Yeah, I am.
Okay, there we go, finally. Sorry about that, okay. All right, so today we're gonna be covering all of the state machine stuff, not all of the state machine stuff. So we're gonna be going over the first state machine tutorial. And let me open up a new window. So on Google, when you search up ROS SMACH tutorials, the first thing that comes up is going to be this SMACH tutorials ROS wiki. All right, we got 40 minutes, okay. And whenever you come here, it's actually split up. It's actually split up pretty nicely. I like the way that it's split up. On the left side here, they have a version of learning step by step. What they do on the left side for these 5 is step by step, they go through everything and they show you like what each line does and how it works. And they go through it like that. But then on the right side, they have learning by example. And over here, they just show you the final state machine. And they have you guys just look at the final one and figure out like, okay, this is how we make this happen. So this left side and this right side actually all cover the same material. It's just, it depends how do you like to learn? Do you like looking at the final version, or do you like going in line by line and like seeing how everything is set up? So for us, we're gonna be going into this first one. This is what we're gonna cover today, is this simple state machine. But before I go into that, I kind of wanted to cover classes in Python with everybody. So just because our team isn't all CS people, there's a good chance that that we don't know what classes are. Let's see if that works. Can I put this over here? Okay. Yeah, so there's a good chance that we don't know what classes are. So I wanted to go into them a little bit just to show you guys like what is a class, what is an object, and what is like the little dot that we used last time. And I'll show you all of that in a second here. It doesn't really matter where we do this. You can put it, like, if you're making this file, you can put it anywhere you want, but I think I'll put it into here. I'll just make a folder for this workshop. How's that? This is number 7, right? Workshop 7. Okay. So I'll clear all that. Yeah, so I just made a workshop 7 folder. You guys can put this file like anywhere you want it, really. It doesn't matter that much. As long as it's in your, as long as you put it in your workspace, like in the source folder, it can be anywhere after that. It might not even have to be in, actually, just to be safe, I would recommend putting it in the source folder, yeah. Yeah, but I'll nano a, like an example kind of fold file. I guess I'll just name it example.py. Yeah, So I'm making this file, it's named example.py. So since it's a .py, you guys already know this is gonna be a Python file. And I'm just gonna try to explain classes to you guys. According to Ricardo, all of the stuff I'm about to go over is kind of like an entire semester long class in CS. But I'm gonna give you like a really quick, like brief rundown of how it works so that we know what we're doing when we go into the simple state machine. Yeah. So yeah, okay. I think we'll just start off with lowercase. I think we'll just start off with this class right here. So a class in Python, you can think of it like kind of like a blueprint. So in it, you're gonna have some information. So like, let's say here, we're trying to make a class for a car. So what are some things that a car might have? It might have like a certain color. It's gonna have a brand. It's gonna have a year. It's gonna have like an engine. It's gonna have like all of this stuff, right? So whenever we're making a class for a car, in every class that you make, you have to have this defined init. And this init is basically like initialization. So every time I make another car, it's going to run this initialization code. And in here, you have to put certain things. So this, I'll try to explain this as best as I can. It's a little bit hard to get your head around the first time you're going over it, but once you guys start using this stuff, you'll get used to it. So in Python, there's this thing called self, and what self lets you do is it lets you make like multiple. Basically, whenever I want to create one of these cars, it's going to be called an object. And I'll show you guys what that means like once I get this part set up. But I'm going to be making an object and it's going to be a car type. And I can actually make multiple different kinds of cars. And what this self does is it lets you give each car its own unique information. So like here, let's say I want to put in a color, a brand, and a year. So every time I make a car, it has to have a color, it has to have a brand, and it has to have a year. And in this initialization part, for now, I think I'll just say pass. So pass means don't do anything. It just means like, just initialize, you give it this stuff and then pass, and that just means like don't do anything. And that's like all I'll put for now. And then down here, after I made the class, now like completely separate, I can make a car. So like I can name my car like whatever I want. Let's say like my car. And then I say that it's a type of car. So my car, it's equal to a car. But I have to give it a color, a brand, and a year. So in between these parentheses, I say, okay, my color of my car, let's say it's green. The brand of the car, let's say it's like a Toyota. And then the year can be whatever year you want. How about like 2015? So now I'm saying that my car is a car type. So it's this class right here. And its color is green, its brand is Toyota, and its year is 2015. So now if I tried to, if I do Control O and then press Enter, it'll just save the file. And then if I make a new terminal over here, you can see the file is here now. And if I do Python example, nothing happens because we're not printing anything out, but it didn't give me an error. So that means that so far my code is correct. But to explain like what is happening here, what I'm gonna do is in here, instead of instead of doing just pass, I'm going to be using this self. So the way self works is it's like, it's a description of every single different car. So like now that I made a my car and I said it's equal to car, this self is referring to this specific my car. And then now we know that it's green, it's a Toyota, and it's 2015. So if I say self dot, I don't want to use the same word here, so I'll use like self dot the color. I can say that that's equal to color. So like over here, I put in green, right? This green gets sent over, yeah, okay. This green gets sent over into here and it gets put into color. And now I'm saying that's myself, so this car dot the color is equal to this color, is equal to green. And then I can do the same thing with all of the other ones. So self dot like the brand is equal to brand, and self dot the year is equal to year. So I just put in all three of this information. I put them into the self. I put them into self. So I put them back into car. And now, like, let's say I save this code and I run it again. Still, it doesn't print anything out, but we still don't have errors. And if I go here and I say print my car, if I did this and I said Python run, it gives you like a bunch of mumbo jumbo. It says like car instance add, and it gives you some random place, and you can't really like understand what's going on there. But let's say you want to grab like a certain aspect of the car, like you want to grab the color of the car. So over here we said self dot the color is equal to color, and from now on, anytime I want to reference this color green, I can use my car dot the color. So if I save this and I go Python, it printed out green. Because my car is an object. The type of it is this car class. I said that the color is green, and then I put the color into self dot the color. So now every time I run, so now my car, it has all three of these attributes. It has the color, it has the brand, and it has the year. And anytime I want to reference one of those, I just put dot the color or dot the brand or dot the year. So like I can go print again my car dot the brand, and I can save that. And then if I go Python, now it prints out green and Toyota. So it's printing out the color and the brand. And yeah, that's all there is to that. And then now the reason these classes are helpful is because now I could make something like my other car. And my other car is also this car type. But let's say this car is a blue, let's just say it's a Honda, and then let's give it a year like 2016. So I have my car and it has this information, but I also have my other car and it has this information. And then now over here, I could say separately, I could say print my other car dot let's just print the brand. All right, so now I'm printing my other car's brand. And so if I run Python here, now I'm getting green, Toyota, and Honda. So color of my car, brand of my car, and brand of my other car. And everything there printed out. And that's how like this class is kind of used. Yeah, sorry if this self stuff is a little bit confusing. The first time you go through it, it's very confusing, but the second you start like actually using it yourself, you can see it's not that complicated. It's actually pretty simple. But yeah, that's that. Are there any questions at this point? I think I should probably stop and ask questions. Hold on. Can't see the chat. Okay. All right. Any questions so far? Does it look good for now? All right, I'm gonna take that as it looks good then. Okay, so then we have all of that. Before I get into the state machine again, I think I should redo this example with a little bit of extra stuff. So if you guys got all of this, I could delete it all. Yeah, okay, I think I'll just delete all of it real quick. If you're gonna take a screenshot or something, now's the time. Okay, I think I'll delete all of that real quick. And then I'm gonna make a new class. I'm gonna go through this. I'll try to go through it quickly again. I'll make a new class, and this one is gonna be, let's make it like kind of like a game. So it'll be like a monster. So like in a video game, you're making a monster. And the same thing as before, define init, and then you give it self, and then there's so many things that a monster could have, right? It could have like a health, they could have attack damage, attack speed, armor, movement speed. It can have like so many different things, right? But for now, let's just say that my monster has, we could do the same thing as before. Let's say it has a color, it has an attack damage, and it has an attack speed, okay? So we have a monster here. It has a color, an attack damage, and an attack speed. And then in the init, I do the same thing. So I say self dot the color is equal to color. Self dot attack damage is equal to attack. And self dot attack speed is equal to speed. So now whatever I put into here gets put into attack damage and attack speed. But now, before I just end it there, I'm actually going to make a function in this class. So just like way back in Arduino, where we would say like void like my loop is something. Here we can say define. What do we want to do? What is it? Damage per second. Let's name our loop that. So I'm making this function here. It's named damage per second. And in Python, you always have to give it self. Because here, I want to pass it this information. I want to pass it the attack damage, and I want to pass it the attack speed. And the way I do that, since I put both of those into self, I pass self into this. So now in here, I can say return self dot attack damage times self dot attack speed. So every time I run this function, it's going to return my attack damage times my attack speed. And then that'll give you your damage per second, right? So like if your attack damage is 10 and you're attacking 2 times a second, you're doing 20 damage per second. So then we're returning that. And then now down here, if I wanna like make one of these, I could say what's a monster, like a minion in a game. A minion is equal to a monster. Its color, let's do the same thing as before. Let's say the color is green. Its attack damage is like 15. And its speed, it's attacking 3 times a second. So now down here, when I want to print, let's say I want to print the damage per second. Just like when we did self dot, so like before, like if I wanted to print something out, I would do minion dot attack damage, right? Because this attack was put into attack damage, and that's part of self. So I would say this attack damage is a part of the minion. And I could print this out. Like if I save this and I run it, it prints out 15, which is the attack damage I gave it. But instead of printing that out, I can also do minion dot this, minion dot damage per second. So now, can somebody tell me if I save this and I run it, well, what is it going to print out in the terminal? Does anybody know? Yeah, thanks for the DM. Yeah, 45. Yeah, exactly. So if I go Python here and I run it, it printed out 45. So what this did is it went to this minion, it went into this, it has its information, it has it's green, it has 15, it has 3, and it ran the damage per second loop. So it ran this loop here, and it gave it its information in self, and then it returned the damage times the speed. So it returned 15 times 3, and we got the damage per second. How much time do we have? We have 20 minutes. I could go more into this. Don't know if I should. Let me see, what else was I planning on going into? Oh, yeah, I mean, you can also, obviously, you can make like other things in here. You can go like monster, black, let's say, because it's a witch, and then like its damage, maybe it's like 24, but it only attacks like 2.5 times per second. And then you save that, and then now if you want to print witch dot damage per second, it prints 45 and 60. So I printed out the minions damage per second and the witch's damage per second. And I just really wanted to show you guys this dot operator here and how like I created this witch. It's a monster type, and it runs the damage per second function that was defined in here with this dot. And that's like all that I wanted to cover. And for anybody wondering what does monsters and cars have to do like at all with State Machine, I'll show you that right now. Yeah, I think I should just go into it right now. We have a little bit of time. I think I'll go into this real quick. So since I made this class named monster, I can actually make another class, and I can name this one, let's go with like player. And I can say that this player is based off of monster. So this here is based off of this up here. And then I can say the same thing before define init self. And then I can, what's a specific thing that a player has? So it might have like a level, right? It's like your player has a level. And what it did was whenever I said that it's a monster type, it automatically gave itself a color. It's like expecting a color, an attack speed, and attack damage and attack speed. And it also gave it this damage per second loop. So like everything in the monster got inherited into here. So like in here, Python is a little bit, Python 2 is a little bit annoying with this because the version of Python I'm using is 2. But to get this to work, you have to add in the word object up here. And in here, you have to put in super player comma self. It's a little bit annoying, just like the way that Python has it set up, but this is the way that you do it. So like you throw object up into here, and then down here, this super is saying go up to here. So like I'm a player and I'm based off of monster. So when I say super, it means go up into monster and run the initialization loop. So run this loop. And then in here, I can define like, okay, every player, every single player that's playing is gonna be blue. Every player is gonna have an attack speed of, I don't know, 40. And every player is gonna have an attack speed of like 1.5. And what this is doing is it's going up into monster and it's running its initialization. And it's saying every single player is gonna have blue, 40, and 1.5 in there. And then you can also say like self dot the level is equal to level. Because I'm also saying that it has a level, right? And then down here, if I just go ahead and delete all of that, now I can say like my player, let's put my name in there, let's say Aren, is equal to a player type, and you have to give it a level. It's like player level 5. And now I can print out a lot of different things actually. I can, since I said it's level 5, I could print out Aren dot the level, but I also automatically, just because I said player 5, it automatically made a monster that's blue, 40 damage on 1.5 speed. So I could say print the color, and I could also say like print Aren dot this same thing, damage per second. And even though I didn't define anything in this player over here, it's like all I did was say class player, it's based off of monster, and then I said player 5. I can run Aren dot damage per second, and whenever I print this out, it says blue and it says 60, and 60 is obviously 40 times 1.5. So it, even though it's not defined here, it inherits everything from up there. And now we're finally done with all of this. If this makes sense, I know it's probably confusing just looking at it the first time. The second you guys start using this stuff, it'll be a lot less complicated. But that's like a general rundown of classes and everything related to it. Oops. And now that we got through all of that, I can show you guys why did we look at that at all? Like why was that necessary at all? So I'm going to click on this simple state machine right here. So the tutorial is only this long. It's literally, this is learning by example. So they just give you the state machine and they're like, figure it out. And you can already see in here, there's a class, it has a name, it's based off of something, and then it has the define init, and then it has another loop down here. And now that we went through all of that, hopefully this stuff is going to make sense to you as well. So I'm going to actually make this a lot larger, and I'll clear it. And then I'll make another file. Let's name this, it doesn't matter. Let me just check this real quick. Yeah, okay, I went over everything. Cool. Yeah, okay. So then, yeah, so we'll just make a file. I can name it anything that I want. It doesn't matter at all. Let's name it our first state machine. So our first smash.py. Our first smash.py, that's what I'll name it. Remember, it's a .py file. That means this one is also a Python file. And like we do with all Python files related to ROS, you want to put bin environment Python at the top of it. The other one that we were just doing was a Python file, but it had nothing to do with ROS. It was just Python. But this one is state machine stuff, and state machine is ROS related. So we put that at the top, and then we're going to import these libraries here. For some reason, me and Ricardo, every time we run this ROS lib load manifest line, it just breaks, and it gives you an error, and it doesn't want to work. So in here, you're supposed to put the name of your workstation. Oh, you guys can't see it. So like my workstation, it's named Aren underscore workspace. And so you're supposed to put like the name of the package into here. But for some reason, it doesn't work. We just deleted it, and it works perfectly fine. So you guys can do the same. Smash ROS. So like just don't include that, and it'll work perfectly fine. If you want to include it, go ahead. And if you don't get an error, I have no clue what you did right. Yeah, so we include all of these libraries, and then now we can start into the actual coding. So what we're going to be making here, our final result in like 10 minutes here, is going to be this machine right here. So it's going to come in. One thing I should say for anybody that's not a CS major, foo and bar, those are just names that they put whenever you can name something whatever you want. So like, you know how whenever I code something, I always, and it tells me like name something loop, I always put my loop, just so I know like I can name it whatever I want. I put a my in front of it. The CS version of that is naming stuff foo and naming stuff bar. That means that whatever you want, you can name it. It has nothing to do with actual programming. So if you want, we can stick with there so we don't get confusing. We're making a class named foo, and it's based off of a state machine.state. So once we get started here, you're going to see why I just spent like a half hour going over all that stuff. So we're making a class named foo, and it's based off of a smash.state. So it's a state machine state. And like we do with everything, we go define init and only self. We're not plugging anything into it. And then if you remember before, we did like super dot init, right? And then we initialize like we initialize this based off of the state machine. But in here, you do smash dot state dot init. And this is the same thing as that. We're initializing this guy here. So we're initializing this state machine. And then you tell it, oh, there's no dot there. Then you tell it yourself. And here, it wants you to give it all the possible outcomes of this state. So if I go up here, I see here I have this foo state. And looking at all of the outcomes, I have one outcome that goes to bar and another outcome that goes here to like finish, right? So outcome 4 is like you're done with the state machine. So foo, it either goes outcome 1 or it goes outcome 2. So this outcome 1 is like the same thing as like continue, because what it's going to do is it's going to continue to bar, and then it's going to come back to foo, and then continue to bar, and then back to foo, continue to bar, back to foo. And then this other one here is like exit. So I'm actually going to say here that the possible outcomes, geez, I can't spell, the possible outcomes of this state is continue and exit. So this state is either going to continue or it's going to exit. And I want to emphasize that so you guys like you keep track, because I'm changing the names up a little bit. So just remember, this is continue and this is exit. And that's that. And then I'll go here and this self dot counter. I could just write counter is equal to 0, but the problem with this is I'm going to have a bunch of different states. And if I want to have another counter in another one, I can't name it counter anymore because I have this one named counter. And then this is going to get into that one. They're going to like start messing each other up, right? So that's where self comes in. So this self, so this state only has this specific counter. So this specific state has this specific counter, and it starts off at 0. And that's all the initializing there is for that state. And then, try to speed up a little bit, and then you have define execute. And this is the loop that's going to execute. So this is the code that's going to run after it initializes. So like it's going to go through all the initialization, and then it's going to execute this code. And then you give it self again, obviously. And you also have to give it user data. We're not going to be using user data in this example, but at the next workshop, we're actually going to use it. But for now, just pretend like it's not there. You have to include it, but just we're not going to be using it, but just include it anyway. So it wants you to do rospy.loginfo. If you remember from the last one, rospy.loginfo is the same as saying print. But we'll stick with their version for now. We'll just do rospy.loginfo. And then it wants you to say executing state foo. So whenever you're running the foo function, so like whenever you're running this state, it wants you to print something out. So I'll just say like running foo. So whenever we're in here and we're running the foo like function, or we're running the foo state, sorry, it's going to say running foo. And then it also has this information here. It says if self.counter, because this counter was put into self and we passed self into here, so it knows what this counter is at. So if self.counter is less than 3, so it starts off at 0 and it's already less than 3, then self.counter plus 1, so add 1 to it, and then you return one of your outcomes. So what this is saying is I'm starting off at foo and my counter is at 0. If my counter is less than 3, come here to bar and add 1 to it. So now my counter is at 1. Then I'm going to come back. It's less than 3, go here. Now it's at 2. You come back, it's less than 3. Now come here. Now it's at 3. You come back, and then you exit. So loop 1, 2, 3 times, and then exit. And so here, if my counter is less than 3, I want to continue. So I'm going to say return continue. And then if my counter is not less than 3, so else, you can say return exit. Okay. Let me know if this is confusing or if this makes perfect sense, by the way. I'm trying to keep track of chat at the same time. And that's all there is to this state. So you have 2 outcomes, continue and exit. Every time it runs this state, it's going to say running foo, and then it's going to continue, and it's going to keep continuing until counter reaches 3, and then it's going to exit. And then now that that's done, I can write my class over here. I can write my bar class. And I already went over all this. You have the smash.state. It's based off of that. And then you have obviously the same thing defined, init, self, and then, whoops. And then you have the same thing as before, smash.state.init self, comma, outcomes. And then here you put in all of the outcomes that the bar has. And obviously, bar, if you look at it, there's only one possible thing it can do is it can go back to foo, right? This outcome 1 right here, it just goes back to foo. So instead of putting it as outcome 1, I don't know why, it's extremely confusing the way that they put it. I'm not a fan. I'm going to rename it to back to foo. And then I'll close that and do that. So now my only outcome for bar is go back to foo. And that's all there is in the initialization. I move over to the execute, and then I do the same thing, self comma user data, and don't worry about user data for this workshop. I'll do the same thing that I did up here. I'm going to say rosspy.loginfo, and this time it's going to be running bar, right? Because now we're in the bar one and we're executing bar. So every time we execute bar, say running bar. Every time we execute foo, say running foo. And then no matter what, you're going to return back. You're going to return back to foo. Right? And then that's all there is in actually coding the states. Makes sense. Okay, awesome. And then that's all there is in the actual states. So obviously, when we're actually programming this for the competition, this execute is where all of the coding is going to be for that specific state. So like if this state is named like avoid barrel, let's say, this execute is going to be where we have all of the code for how it avoids the barrel. And then all of the different outcomes it could have is like maybe return I hit the barrel, or return I lost the barrel, return I passed the barrel. Like there could be so many different things that you return, and you're going to have a bunch of code in this execute. But for now, it's just print. It's literally just like print that we're doing it. And then down here, it says define main. It's like your main loop is what it's trying to say. Obviously, I like to put my loop. So my loop, I'm going to define my loop. So now that we got all the states out of the way, we want to define my loop. And rosspy.init node, if you guys remember from the last workshop, is initializing this node as, it's initializing this state machine as a node. And you can name this whatever you want. It really doesn't matter. I'll name it like our state machine. It really doesn't matter what you name it. But I'll put that in there. And then here, SM is equal to smash.state machine. If you guys remember, this is like what we were just going over as well, is this is a variable. Look, think of this as like Aren. It's equal to this player type, and you're giving it this information, this outcome, right? So now here, you can name it whatever you want. They use SM as short for state machine. We'll use like my SM, so you know that we can name it whatever you want. My SM is equal to smash dot state machine, and then its outcome. The outcome of the state machine means what is like the final thing that your state machine has. Like what's the last thing that you do? And in here, the final outcome here is outcome 4, and that's like you're finished, right? It's like you loop 3 times, and then you go from exit. This one we named here exit. You go from exit to finished. So I'm actually going to name this one here finished. So the final outcome of my state machine is being finished. And then here you say with, I renamed it, so I have to put with my SM. So this means like open up this state machine and put this information into it. And the information we're going to put into it is the 2 states that we made. So smash.state machine.add means add this state into the state machine. And remember, like this dot add, this is a function. So like we're giving it this following information. This following information goes into it, and it's going to add this into this my underscore SM. And here you can name this you can name this one whatever you want. I'm just going to go with there. It's just because we're running over time. So here you put in the name of your loop. I named my loop foo, so I'll put foo there. And then you give it your transitions. And this is the only tricky part really about the state machine, is getting your head around the transition. So here, I named this transition here continue, because it goes from foo through continue, and then it goes to bar, right? So when foo returns continue, you go to bar. And when foo returns exit, you go here to outcome 4, which I named finish, right? So here in transitions, I say transition from continue to bar. Okay, so we're transitioning from this continue, this outcome continue, to this bar right here. And the reason the bar is capital is because over here, in like a second here, I'm going to be naming it capital bar. Yeah, and then you also have the other thing over here, the other transition, which is exit. And you transition from your exit to finished. And let me make this a little bit larger so it fits. Yeah, then I'll close that. So this is the tricky part right here. We're going from continue to bar, and we're going from exit to finished. Okay? Once we get that, we can move on to the next, adding in the next state. So smash.statemachine.add, and we're going to name this one bar, and it's this bar loop right here. Oops, not bar 90. Bar loop, and then its transition. The only transition it has is this one here, named back to foo. So it transitions using back to foo, and it transitions to this foo state. So to foo. So just to run over that one last time, we're going from foo using continue to bar, and then from bar using back to foo, we go to foo, and then continue to bar, back to foo, and then exit to finished. And that's our entire state machine there. And then down here, you can say outcome is equal to my SM, because I renamed it to my SM dot execute. And what this does is it executes your state machine. So this means, okay, we added everything into it, now run the state machine. And then at the very end, if you guys remember from the other tutorial, again, I'm going to keep referencing the old ones, we have this if name equals main that you have to run in Python. And then you give it your loop, and I named it my loop. So in here, I'm going to say my loop. And if I save this, and I open up a new terminal, and I do ls, you can see our first smash.py is here. And if I do Python, no, almost made a mistake. You have to, since this is initializing a node here, that means that we're using ROS. And then every time you use ROS, you have to run ROS core. So now ROS core is running. Just keep that in mind as ROS core is running. I'm going to minimize that. And now we can run our state machine. And if you look at it here, it ran this. So it's that starting state machine in the initial state foo with user data blank. So with no user data, because this one we're not using user data. And then it said running foo. So that means that we're running foo, we're in here. And then it says state machine transitioning from using foo, no, from foo, using continue, it goes to bar. So if you look over here, from foo, using continue, we went to bar. And then it says running bar, which was down here. And then it says transitioning from bar using back to foo, and then it goes to foo and it runs all of that. And then finally down here, it says running foo, state machine terminating from foo using exit, it goes to finished. So foo, exit, finished, or state machine terminated. And since it's a little bit hard to see it like this with like their names and everything, what I'm going to do is here, if you click on back, learning step by step, tutorial 5, it actually shows you the 4 lines you have to add to view a state machine. Sorry, 5 lines you have to add to view a state machine. I guess it is 4 actually, because this one's already here. So it says, okay, go to the bottom. It says create your state machine, and then go through all of that. And then right here, you have outcome equals sm.execute. I have outcome equals my sm.execute. So above that, I have to put in this line. So right here, I have to put in sys is equal to smash underscore ross dot introspection server. You can put this, you can name this sys whatever you want. I'm just trying to go quickly so we don't run out of time. Server name, you can name it anything you want. It doesn't matter at all. I'll just name it, doesn't matter. And then in here, you have to put your state machine. Mine is named my SM. And then you put in the name of like the very top of the machine, name you want at the very top of the machine. It doesn't matter at all what you name it. I'll just name mine Aren's state machine. How's that? Let's put some of those in there. And then you're done with that line. So this doesn't matter. This one you give it the state machine, and this also doesn't matter, but I'll give it a name just because it shows on the actual thing. And then you say sys.start. And if you rename this sys here, you have to put whatever the name is into here. Then I have my outcome line right here. And it also wants rosspy.spin, and it wants sys.stop. So what this is doing here is it's basically saying until Control C is pressed, so until I press Control C, keep spinning and keep running my state machine. And then once I do press Control C, then stop. Then stop everything and you're good to go. And since my bottom part disappeared, I'm gonna delete a line up here. Okay, cool. Brought it back. There. Now it actually fits. The whole code fits in here. Okay. And now, oops, I don't want to open up files. Okay. Now I have ROS core already running. I'm going to open up this terminal here. So this terminal is the one that runs the state machine, right? And now I'll open a new one up here and I'll say ROS run smash viewer.py. And it'll give you a couple errors, but then it'll eventually work, right? So now in here, I have my smash viewer, and you can see in path, there's like nothing in here. That's because I haven't ran my state machine yet. So when I press Python our first smash.py, it runs the machine. And if I click up here, Aren state machine is available now. And then if I click it, it shows me, it gives me a visual of my state machine. And then if I make this larger and I say focus it for me, didn't come out too great, but this is the visual of your machine. So it says Aren state machine. It starts up with foo. Foo goes from continue to bar, and then it goes back to foo, continue to bar, back to foo, and then using exit, it goes to finished. And then that's visualizing the state machine. And sorry for going over time. I'll press Control. If you want to exit this, Control C, and it leaves it. That's what that rosspy.spin was for. And then I can X this out, I can X this out. I can Control C on ROS core and it'll shut that down. And then Control X over here and we'll leave that. And that's how we get our first state machine working. So this is the entire full state machine. You do ls and we have our first smash.py running. Yeah, and that's everything. Are there any questions at this point? Are we good? Anybody confused? Anybody confused on any of that? Or are we good? That was just going through the very first simple state machine, and then the viewing state machines is something you add on to it. For you guys, you might have to download this Smash viewer thing. It should have a download somewhere. But yeah, yeah, the actual state machine stuff is actually pretty simple. It's just getting your head around this self thing. Once you get that, it should be pretty simple to figure all this out. Yeah, but next time we'll go over that user data stuff, and we'll go over like this nesting state machine stuff. But yeah, that was everything. If there's no questions, I can stop the recording and I'll stop sharing as well. Yeah. Okay. Looks like we're good then. All right. Thank you everybody for coming. I'll stop the recording over here.